Welcome to my class Physics Untold. Here I am representing a question from 300 creative problems by Holics, and this is problem number 32. The question is, a cart of mass 3 kg is pulled by a 5 kg object as shown. The cart, whose length is 40 centimeter, moves along the table without friction. There is a brick of mass 2 kg on the cart, which falls from it 0.8 second after the start of motion. Find the coefficient of kinetic friction between the cart and the brick. Use G equal to 10 meter per square second. So here first of all, if we describe this question, so in the figure or diagram shown, there is a table on which there is a pulley, there is a fixed pulley, and by the fixed pulley a string is passing over the pulley, and the lower end of the string is fixed with a 5 kg mass, and the another end of the string is fixed with a cart whose mass is equal to 3 kg, and on the cart there is a brick whose mass is 2 kg. And as we are observing that this 5 kg is greater than this weight of the cart, therefore by the weight of the cart, by the weight of the block or mass, the cart will move in the forward direction, and when the cart is move in the forward direction, the brick will slip on the surface of the cart. And as also it is mentioned in our question that this surface is totally frictionless, there is no friction. So in this surface, F equal to 0 or mu equal to 0. So if we analyze this question again, then as the block moves down, there will be an acceleration which acts in the downward direction. This is the acceleration of the block, and if the block moves with a certain acceleration, then this cart also moves with the same acceleration in the leftward direction. Let this acceleration is equal to a, and there is a tension which developed in the string. So this is our tension of the string T. And if we observe the cart, then as the surface between the brick and the cart is not frictionless, or there is some certain friction in between the surface of the cart and the surface of the block. So if first we draw the surface of the cart, then this is the surface of the cart, then there is a friction which generates as the tension is acting in this direction. So tension is acting in the direction, so direction of the tension here which pulls the cart in the leftward direction. So this is our tension force T, and due to this tension force, the cart will gain some acceleration. So this is the acceleration which is gained by the tension force, and it is experienced on the car or cart. And as our applied force is leftward directions, therefore our direction of the friction force, so friction in between in this surface will act in the opposite direction of the tension. Therefore we can say the direction of the friction force is in this direction. So this is our friction force. So F equal to mu into n, which is directed in the leftward direction. So if we write the laws of motion here, so from the laws of motion we can write and also it is mentioned in our question, the mass of the cart is equal to 3 kg. This is 3 kg. So we can write the mass of the, we can write this equation for, if we take the equation of the block first, then for this block its equation will be its mass, which is equal to 5 kg, 5 kg minus 5 kg, which is equal to 50 newton, minus its minus tension T, equal to force into, equal to its mass into acceleration. Its mass is equal to 5 kg, mass of the block is 5 kg, and its acceleration is equal to A. Let this is our equation number 1. And if we consider about the cart, then from the cart we can write here the force T minus mu n equal to the mass of the cart, which is equal to 3 kg, into acceleration of the cart. So let this is our equation number 2. Now we can solve this equation for getting the acceleration, of the cart. So here T and T will get cancelled. After this cancellation we can write this 8A equal to 50 minus 8A equal to 50 minus mu n, or we can write the acceleration of the cart, which is equal to 50 minus mu n, 50 minus mu n divided by 8. So this is the acceleration of the cart. Now when the cart moves in the leftward direction, there is some friction between the brick and the surface of the cart. So due to this friction, and this friction acts on the brick in the opposite direction to the direction of the friction of the block, or direction of the friction of the cart. Or here it is also given that the distance of the cart surface is equal to 40 centimeter, so which is equal to 40 divided by 100 meter. And so due to this friction, so as the cart moves in the rightward direction and friction acts in the same direction, so there will be a pseudo force generated. A pseudo force will generate in the opposite direction, opposite direction to the acceleration of the cart. And due to this pseudo force, there will be a pseudo acceleration which moves the brick in the leftward direction. So, and due to this pseudo force, the brick gradually slides in the leftward direction, and after certain time interval it falls from the surface of the cart. So if we observe on by the reference frame, or if we observe from the cart surface, if our observation is from the cart surface, and the object is 2 kg, or if we observe the 2 kg block, the motion of the 2 kg block on the reference frame of the cart, then the displacement covered, here we can write the S, or displacement of the brick with respect to, or on the reference frame of cart, equal to 40 divided by 100 meter. And in this time the time taken, and to cover this distance or this displacement, the time taken t equal to 0.8 second, or we can simply say that in t equal to 0 second, or when the motion starts, after 0.8 second of the starting of the motion, the brick will cover a distance of 40 divided by 100 meter with respect to the frame of the cart. Now if we analyze the case what is happening here. That is, this is the surface of the cart. If this is the surface of the cart, and as the brick is very small or very tiny in size as compared to the length of the cart, so this is our brick, and as the friction appears here, so this is our friction F equal to mu n, which act in the rightward direction, because for the cart surface the friction is opposite. The tension is opposite to the tension force, because tension is the driving force. But now in the case, the brick is driven by the cart. So therefore the direction of the friction force in the forward direction or in the leftward direction, or reversely we can say, as the tension appears here, or due to this tension the cart will appears a pseudo acceleration. Let this pseudo acceleration in this case is here. So due to this pseudo acceleration, a pseudo force will appear. So this pseudo force equal to its mass of the brick, which is 2, into its acceleration a. So this pseudo acceleration which generates on the brick, and the friction is appeared here, and it is also given in our question that this length is equal to 40 divided by 100 meter, and also the motion starts from rest condition, or we can say the u, or initial velocity of the system, is equal to, or initial velocity of the brick with respect to cart is equal to 0. Now we can, if we write the force of, so if now we can write the equation of the motion, laws of motion equation for the brick, and for this brick we can write the acceleration of the brick with respect to cart, which is equal to a bc, or acceleration of the brick with respect to cart, and if we multiply this with its mass 2a, then it is also acting in the direction of in this direction, because ultimately the brick falls from the surface of the cart. So when this falling happens, and it indicates that the net acceleration, the net displacement will be in the opposite direction to the motion of the cart. Therefore, and also the acceleration of the brick with respect to, or in the reference frame of cart, is equal to ABC. Therefore we can write its mass of the brick, which is equal to 2, into acceleration of the brick with respect to the cart reference frame, ABC, which is equal to the force, pseudo force, which is equal to 2a minus its opposite force, which is equal to mu n. Let this is our equation number 3. And also the displacement covered is, so SBC, or displacement of the brick with respect to, or in the reference frame of the cart reference frame, will be equal to UT equal to UBC T plus half ABC T square. Now as the motion starts from 0, or initial velocity of the brick is 0, because it starts from the rest. Therefore you can write UBC equal to 0. Therefore the first term will become 0, or we can simply say the SBC. Now the value of the SBC is nothing but it is given in our question equal to 40 divided by 100, which is equal to half into ABC. Now we can write the equation for ABC, which is equal to 20 equal to 2a equal to 2a minus mu n divided by 2 into time taken in this process, which is equal to 0.8 second squared. Again we can substitute the value of a from equation number from this equation, or we can write here 40 divided by 100 equal to half into, now this 2 and this 2 will get cancelled, so if we cancel this 2, then we can write here it should be equal to 50, the acceleration a, which is equal to 50 minus mu n divided by 8 minus mu n divided by 2 multiplied by 8 divided by 10 multiplied by 8 divided by 10, or 64 divided by 100, 8 divided by 10 square, or 64 divided by 100. Now we can cancel this 100 from both sides, and we can again cancel this. This will be 10, and or if we cancel this by 8, then there will be 5 and there will be 8, or again we can write, or we can simplify this equation, as here the equation is equal to, here the left side is equal to 5, which is equal to half into, so if this half goes in this side, then it should be equal to 10, so 10 should be equal to, and here the LCM of 8 and 2 should be 8, or in the numerator term there is 50 minus mu n minus 4 mu n which is equal multiplied by 8. Now this 8 and 8 cancel out, or we can write here as 10 equal to 50 minus 5 mu n. Again we can substitute the value of n from here, because here the weight force acting, which is equal to 3g, or 3 into 10 means 30, and in the upward direction the normal reaction acts, which is n, or instead of n we can replace here 30, or we can write the equation as 10 equal to 50 minus 5 into 30 into mu, or 5 into 30 mu equal to minus or equal to 40. Then this will be then we can cancel here this 0 and 0, or value of the mu will be equal to 15 divided by, or if we simplify the value of n, so value of n. Now this n is not due to the weight of the cart, but this n is due to the weight of the brick, because we are only considering here about the motion of the brick. So here this should be equal to the, here is the weight of the brick, which is equal to 20, and normal reaction will act in the upward direction, or n is in the upward direction, or this n will balance the value 20, or instead of n we can write here 20. So here will be 20, and if we cancel this 0 and 0, then the left hand side is equal to 10 mu equal to 4, or we can write the value of mu, or coefficient of friction, should be equal to 4 divided by 10, which is equal to 0.4, which is equal to 0.4. Or our required answer, the asked question is, find the coefficient of kinetic friction between the cart and the brick. So coefficient of kinetic friction mu between the cart and the brick, which is obtained as 0.4. Here the answer or solution of this problem. Thanks for watching this video. Thank you.